Alright, so let's analyze this mixed circuit. So we've got 5 resistors, we've got R1 and R2 in series with each other, R4 and R5 in series with each other, and then they're all in parallel. Okay, so we're going to need to simplify this circuit. We're going to try to replace R1 and R2 with a single resistor, and we're going to replace R4 and R5 with a single resistor, so it's completely in parallel. So let's redraw our circuit with our simplified resistors. So we've combined R1 and R2 into one resistor. We're not changing anything about R3, and we're combining R4 and R5 into one resistor. So now we have a simplified circuit, and it's completely in parallel. So we need to figure out what the replacer, we're going to replace R1 and R2 with, what that resistance is. Well, since R1 and R2 are in series, we can replace them with one resistor that equals their resistances combined. So R12, our new resistor, is going to have a resistance of 9 ohms. R3 is not going to change. And we're replacing R4 and R5. They're in series with each other, so we're going to be adding their resistance. R4 plus R5 will give us the resistance for our new resistor, R45, and that's going to have 5 ohms of resistance. So we've created our simplified circuit. It's still got the same voltage. R3 is still the same resistance. Okay, we want to completely analyze the circuit, figure out the voltage drops across all of the resistors, the current, and the effective total resistance here. So we'll make our table. Our table is going to have voltage, current, and resistance as the rows. Our columns, we'll have a column for the totals. We'll have the columns for what's going across resistor 1, 2, 3, 4, and 5. So one column for each resistor, plus a column for all of the total values. Let's fill it out with some stuff we already know. So we already know that the total voltage here is 5 volts. We also have the values for the resistors. Resistor 1 has 5 ohms, resistor 2 has 4, resistor 3 has 6, 4 has 3, and 5 has 2 ohms. So we filled out all our free information. Now we're going to have to do some calculations. So let's go ahead and calculate the total resistance. So the total resistance here, well, our equation for total resistance, 1 over the total resistance equals the sum of 1 over each resistor. So we're going to use our replacement resistors, so 1 over R12 plus 1 over R3 plus 1 over R45. We'll plug in those values, so we get 1 over the total resistance equals 1 over 9 ohms, plus 1 over 6 ohms, plus 1 over R45, 1 over 5 ohms. So we can add those all together in our calculator. We can use our fraction tricks, understanding fractions, but we'll end up with 43 over 90 ohms. And that's 1 over RT. That's not RT. We want RT. So we're going to need to flip it. We're going to need to take it to the power -1. So we should get 90 over 43, 90 over 43, or if we put it into decimals, about 2.09 ohms of resistance. So that gives us the total resistance. So to fill out the rest of the columns, let's just get rid of all this right here. Well, what are some other things we can find now? We've got all of the total resistances. Well, anytime we've got our table set up like this, if we have 2 values in one column filled out, we can find the other one using Ohm's law. Voltage equals current times resistance. So we're looking for current here, total current. So total current is going to equal total voltage, which is 5 volts, divided by total resistance, which is 90 divided by 43, or 2.09 ohms. So if we plug those into our calculators, we're going to get about 2.389 amps of resistance. I don't really have room for all those decimal places, so from now on, I'll just do 2 decimal places. The more decimal places we have, the more accurate we'll get whenever we double check some of our answers later. Alright, so we found the total current. Okay, so how do we find the current for the rest of the circuit? So we know the total current. So we've got 2.389 amps. Well, some of those amps are going to go up leg 1 through resistor 1 and resistor 2. Some are going to go through resistor 3. And then some are going to go through resistor 4 and 5. So we know that the total current, or we know that the current in leg 1 is going to be the same through resistor 1 and resistor 2. Because they're in the same leg, they're in series, their current is the same. Same thing with resistor 4 and 5, they're going to have the same current. We also know that the total current is going to be the sum of all the currents in the legs. So if we add up current 1, which is going through resistor 2 and resistor 1, current 3 and current 4, which is going through resistor 4 and 5, we should get the total current. We don't really have enough information to use that to solve anything right now, but we can use this to double check later. But another thing we know is that the voltage drop across each leg of the parallel resistors is going to be 5 volts, the total voltage. Since R3 is the only resistor in its leg, it's going to have a voltage drop of 5, the same as the total voltage. So that also tells me that the voltage drop across resistor 1 and 2 should add to 5 volts, and the resistor drop across 4 and 5 should also add to 5 volts. That doesn't give me enough information to find out what they are now, but that's something I can double check my answers with later. Alright, so how do we actually find the voltage for 1, 2, 4, and 5? Well, we're going to need to use Ohm's law here. So we know that that voltage drop across 1 and 2 should be the same as the current going through 1 and 2, which we can just call current 1 because they're the same, times the resistance of 1 and 2. We know what the resistance of 1 and 2 combined are. That's 9 ohms in our simplified circuit. And we know what those voltage drops should add up to. Those are 5 volts. So let's just rearrange this equation. We'll get current by itself here. So current 1, which is equal to current 2, also equals that total voltage drop across that leg of the circuit divided by the total resistance of that leg of the circuit. So if I plug in my numbers there, total voltage drop is 5 volts. Total resistance of that leg, R12, is 9 ohms. So 5 divided by 9 should give me my answer here. So that's the total current going through, or that's the current going through resistor 1 and resistor 2. I get about 0.6 or 56 amps. Alright, so I found the total current going through that red leg of the circuit. Now, I can do the same thing for the last leg of the circuit, the blue leg of the circuit, where resistors 4 and 5 are. So the voltage drop across resistor 4 and 5, which should be 5 volts, should equal the current going through 4 and 5, which we'll just call current 4 here, because they're the same, times the resistance of 4 and 5. So I'm going to divide both sides by resistance. I get current 4, which equals current 5, which equals the voltage drop over 4 and 5 divided by the resistance of 4 and 5. Remember, whenever I'm in series, I add voltages and I add resistances, but current stays the same. So these two are in series with each other. So I get 5 volts divided by 5 ohms. So that tells me that the current going through the blue leg of the circuit, going through resistors 4 and 5, is 1 amp. And so now, all of the columns in my table have 2 values, so I can use Ohm's law to find the missing values. So if I want to find the total voltage across resistor 1, well, now I can use Ohm's law. Voltage equals current times resistance. I know what the current is. I know what the resistance is. So V1 equals I1 times R1 equals 0.56 amps times 5 ohms. And that gives me the voltage drop across resistor 1, which should be about 2.78 volts. So I'll fill that in my table. I know that voltage 1 and voltage 2 should add up to 5 volts, so I could be really lazy, and I could just subtract 2.78 from 5. But I also do have enough information to use Ohm's law here. So voltage 2 should equal current 2 times resistance 2, or 0.56 amps times 4 ohms. So that gives me a voltage drop of 2.24. And if I add those together, I should get something approximately about 5 volts. Oh, there'll be a little bit of error introduced with rounding, of course. So now doing the same thing for resistor 3, well, in this case, I know voltage is 5 volts, and I know resistance is 6 ohms. So I'm going to rearrange my equation. I get current going through 3 equals voltage drop across 3 divided by resistance of 3, or 5 volts divided by 6 ohms. So that tells me that the current is 0.83 amps. So 0.83 amps of current. If I add one of the currents going through 1 or 2, plus the current going through 3, plus the current going through 4 or 5, it should give me the total current, 2.389. Alright, so trying to find the voltages for 4 and 5. Well, voltage of 4 equals current going through 4 times resistance of 4. 1 times 3 is 3 volts. And then to find the voltage going through 5, I take the current going through 5 times the resistance going through 5. So 1 amp times 2 ohms should give me about 2 volts, which I should notice the voltage going across 4 plus the voltage going across 5, 3 plus 2 gives me 5 volts. So that matches with my total voltage. And there we have it. We have completely analyzed this circuit.